Okay, now we're going to look at genetic mutations. If you will please watch this video that I have included from the Amoeba Sisters, that would be fabulous. But we are going to be talking about realistic genetic mutations. What you see here in X-Men, that's not real. Now, there's a couple of different types of mutations that we're going to look at. We're going to start first by looking at nitrogen base mutations. And the first type of nitrogen base mutation that we're going to look at are called point mutations. So when we're talking about a point mutation, we're talking about a single nitrogen base that has been affected. So there are several different types, as you can see them here. This first, in this graphic here, the first picture that we're looking at is the normal DNA sequence, and then the mRNA, and then, of course, at the level of the protein. So we're looking at the amino acid. And you're seeing the different types of mutations here. The silent, which if you notice with the silent, it's as if it did not happen at all because it results in the same amino acid sequence. And then if we look over here at the nonsense, then this is going to result in a stop codon and the end of this protein sequence. The missense, we've got conservative and non-conservative. So with the conservative, with the single change that you see here, this substitution, this little switcheroo, it results in an amino acid that is very similar to the one that's supposed to be there compared to the non-conservative, which is going to result in an amino acid that's going to be very different from the one that's supposed to be there and probably will affect the functioning of the protein. So the definition for substitution, this is a mutation that has a change of a single DNA base sequence. So a single DNA base sequence. And when it comes to these types of questions that you might encounter on the SOL, there's a lot to do with pictures. So that's why I have several pictures of these as we go through. And you can see the original sequence versus the sequence after a substitution. So again, going through these just really quickly, the silent mutation is as if it did not happen. It's not going to be detectable by looking at the protein sequence or the amino acid because it produces the same amino acid. The nonsense is going to change that amino acid to a stop, so that's very problematic. The missense, the conservative, that amino acid is similar, so you might not notice. It might not be problematic, whereas non-conservative, it is going to be a different, structurally different amino acid. It's probably going to affect the functioning of the protein. The next type of mutations are called frame shift mutations. And the frame shift mutation, and I have a definition here, but when you're talking about a frame shift mutation, you're talking about either an insertion or deletion of a base that's going to mess up your whole entire genetic sentence after the point of the mutation. So it's going to shift your reading frame. Because remember, we're reading in sets of threes, 1, 2, 3, 1, 2, 3. We look at these in sets of codons and anticodons. So if you add in a base or if a base is left out, then that's going to mess up your sequence of threes. And again, looking at the pictures here, the insertion, we see that this T was inserted between the A and the G. And with the deletion, we see that the A was left out. And you could see what would happen to your codons and then ultimately your amino acid sequence. So again, looking just a little bit closer at another picture, this insertion of a nitrogen base, we can see with this situation that we end up with this straggler, this G here, that is not going to form any type of amino acid. And then we also see that after the point of this insertion of this U, that the amino acids have changed in the sequence. Same thing with the deletion. So in this case, having this U deleted is going to change your sequence. Sorry, it's the C, it's deleted. Duh, it's in red. It's going to change your sequence there, and now this becomes, when this G moves up, this is going to become a stop codon. So now this amino acid, this protein sequence stops here. Okay, the next type of mutations are chromosomal mutations. So that is a mutation not of a single nitrogen base or the nitrogen base sequences after a point of mutation. This is the actual chromosome itself. So there's several different types of chromosomal mutations, and they sound very similar to what we just saw there with the nitrogen base situations. Inversion is flipped, duplication, um, additional parts of a chromosome, deletion, parts left out, insertion, extra parts are in there. And translocation is one piece of one chromosome attached to a piece of a different chromosome, so non-homologous chromosome pairs. And I have lots and lots of pictures for you to look at there for these as examples of what these might end up looking like on an SOL test. So we'll just look at these really quickly, definition and the pictures of them. Duplication, where you have extra copies of a particular section of a chromosome, and you can see in the picture what it looks like here. So we have a duplicated section here. So we have whatever this gene is at section B, we've got an extra section of that. Deletion, to receive part of this is broken off. Maybe this is something that happens during crossing over, and a portion of this just gets lost because it doesn't make contact with its homologous chromosome pair. Inversion, so we see a little bit of a flipping. So again, maybe during crossing over, this piece is broken off and it reattaches upside down. Translocation, so this is between non-homologous chromosome pairs. So we know that it's perfectly okay for crossing over to occur between homologous chromosome pairs, but not between non-homologous chromosome pairs. I do have a little video here that I'd like for you to pause and look at this video. I think it's trying to play on me, but I don't want it to play right now. You can look at it on your own. And then the last thing is what this video is about, is looking at those big picture mutations. So this is going to look at something called non-disjunction. So if you're looking at the big picture and you're trying to find to see if a child has all of its chromosomes, it's 46 chromosomes, those 23 pairs of chromosomes, and you might do something called a karyotype. And we've seen these before. And a karyotype is going to show you all of the chromosome pairs by chromosome number, and you can see them here. And if you have extras, that's a genetic disorder. If there are missing chromosomes, that's a genetic disorder, or even missing parts of a chromosome. So when you look at a karyotype chart, you can see, as we see here, this person, this normal male, has all 46 chromosomes, and we do know that this is a male because of the X and the Y chromosome. So you can also see gender. But then again, you can also see genetic mutations. So in Edwards syndrome, this individual, this male, has an extra 18th chromosome. So this would be referred to as trisomy 18. So instead of having the normal 2, we have 3 of a chromosome. Patau syndrome is also referred to as trisomy 13. And then Klinefelter syndrome, this one has an extra X chromosome.